Okay, today we're gonna take a look at the EEC 141 experiment number 1, or lab number 1, okay, measurement of resistance. For today's lab, we're supposed to finish two tables here in the classroom, in the lab, and another table, which is table 4, at home. Okay, the table 4 is in the further investigation part, and it's basically about the color band interpretation. Okay, so you can actually finish that at home if you like. If you don't have enough time here. So, but you definitely need to fill in the blanks. Fill in the tables for table 2 and table 3. Okay. Usually, I would recommend everyone to read the, for example, in lab number 1, to read page 8, 9, and the first half of page 10. Okay, before you actually come to the lab. And when you get into the lab, you can start working on the lab from procedure number 1, which is the second half on page 10. This is usually where you can actually get started. And also one thing I would like to mention is that usually for each lab, in the first page of each lab manual, you will have a section called materials. This is basically the section where you can find all the materials you're gonna need. For example, for today's lab, we're gonna need 10 assorted resistors and also 1 potentiometer. Here, what you can see on the screen is actually the trainer we're gonna use for the entire semester. So basically, you will find breadboard, power source, and also 2 potentiometers down here. So in our lab 1, you just need to get 10 resistors, and that's it. And you can use the potentiometers down here. Okay. Okay. A little bit introduction on the trainer we're gonna use for this semester. Okay. So this is the trainer we're gonna use, and you can see here, this part, this is the switch. After you plug in the trainer, when you turn it on, you can see the LED is actually gonna be light up. Okay, but like I said in the lecture, when you're actually hooking up the circuit on the board, on this breadboard, making sure that you have the switch turned to be off. Okay, so when you hook up the circuit, when you finish everything here, then you can turn it on to do some testing. Okay. Here we have 2 knobs here, and those are the power source actually. So you can see from here, maybe you can see from the maybe you cannot see it right now, but you can check it your own board, and here you will see a label said +V. Okay, it means that it's going to provide a positive voltage from this knob. And here is going to be -V. Okay, -V. It means that it's going to provide a negative voltage. For this course, we're gonna just use the positive voltage, so this is the only knob that we're gonna use. Okay, we're not gonna use the negative one for this course. So how can I actually connect this knob to my circuit in here? Okay, so you can see here we have 4 knobs in here. The red one you can see is connected to the first line of this this long breadboard. Okay, so we have labels here, you can check it real quick. So the 5 volts is connecting to the first row of hose, and the 1.3 to 15 volts is connecting to the second row, and negative 1.3 to negative 15 volts is gonna be the 3rd row, and the last row is connecting to this one, which is the ground. Okay, so that basically explains how we can actually connect our circuit to our powers and our ground. So we're gonna actually imagine we have a circuit in here, and we want to introduce the positive voltage to the circuit. We just need to connect from the second line, second row, to whatever circuit you're supposed to connect to. Okay, so that's the powers. And for this semester, we're just gonna use the second row and the fourth row, or the last row in here, because the last row is always the ground. It will function like the negative terminal of the power supply or a battery here. And for the positive, we can actually either use the first row and the second row. But you know, the first row is connecting to the positive 5, so it's a fixed power supply. For example, if you really need a 5-volt voltage, then you can definitely use this one. Use the first row. But in most cases in our lab, we either want like 10 volts or 15 volts or 12 volts. In that case, you need to use the second row, because in the second row, by turning this knob, you will be able to supply a power ranges from 1.3 volts all the way to 15 volts. That tells you when you hook up the circuit, you always use the second row as your positive terminal of the battery, you know, on your circuit. And then by turning this plus V knob, then you will be able to change your power supply. You will be able to tune it until, you know, whichever voltage you're looking for, either 10 volts or 12 volts or 15 volts. Okay. All right, so this is the breadboard. This is actually where we're gonna put our circuit on. Again, this little part is for the power source only. I mean, the positive and the negative. But for this square, well, this is actually not one single breadboard. If you take a close look at it, it's actually has 3 parts. Okay, we have 3 breadboards in here. Usually we will not gonna deal with a very complicated circuit in this class, so you can use either one. Usually I will just usually use the one in the middle. Okay. I have a handout on the blackboard, basically that explains how the breadboard is actually working. So you can take a look at that. But basically, how it works is like this. So you can see there's like a gap in here, meaning that the hose on your right hand and your left hand are basically separated. Okay, so all the hose, if you check out the handout, you will know all the hose in the same row on the same side will actually have the same potential, meaning that underneath the board they're actually connected with metal. So meaning that all the 5 holes in the same row, they're actually equivalent. Okay, so in this lab, we're gonna actually do some measurements of the resistors. So the first thing we want to do is to put the resistors in. Okay, so in order to avoid the situation that the resistors are being shorted, so what I usually do is I usually put the resistors into the circuit like this. Okay, so I usually put this across the little gap in here, because in that case I will know those 2 legs will definitely not be connected together or created a short circuit in this case. Okay, so this is what you can do. You can put all the 10 resistors here. You know, just line up all the resistors here, and then you can do the measurements. It's going to be more, I will say, more efficient. Okay. One thing that you have to avoid is to hook up the resistor like this. Previously, I said all the holes in the same row on the same side, they're actually equivalent, electrically equivalent. So you definitely don't want to do something like this. See here? So in this case, you are connecting the resistor in the same row. So I said all the 5 holes here in the same row, they are electrically equivalent. So in that case, the resistor, the two legs of the resistor are connecting to the same point, meaning that the resistor has been shorted. Okay, so this is definitely something you should try to avoid. Actually, you know what? You can give it a try. You can use later on. You can use your multimeter and trying to measure the resistance between across this resistor, and you will see the resistance is 0. Okay, so definitely try to avoid something like that. Okay. Okay, I'll put it back. Okay, now we're gonna, okay, we can talk about measurement later on, okay? Let's talk about the potentiometers first, okay? On this trainer, we have two potentiometers, and you can see this one is labeled as 10K POT. POT is short for potentiometer, and this one is 1K. Meaning that the maximum resistance the potentiometer can reach is 10K and 1K respectively. Okay. If you do the measurement, you will see actually it may not go all the way to 10K. Maybe the maximum is only like 9K or even 8K. That is totally fine. That's why we need to do the measurements, right? We don't. We will not like 100% trust the label value, just like the resistors. So for example, this resistor, by reading the color code or the color band, it should be brown is 1, green is 5, and red is 2. So it's 1.5 times 10 to the second. So basically this resistor should be 1.5K. But when you do the measurement, you will see it's actually a little bit less than 1.5K. Okay, so the label value is just to give you an idea on like the range of this resistor or potentiometer. So if you want to know the exact value, you still have to do the measurement, okay? Okay, let's come back to the potentiometers. So for the potentiometers, you will see we have a little like breadboard in here, basically from the lecture and also from procedure number 4 on your page 10. On the lab manual, you will see usually a potentiometer will have 3 legs. Okay, so if you take a close look at here, okay, there are labels here, and they are labeled as 1, 2, and 3. Basically, that tells you the 3 pins. That's the 3 pins. So the first 2 holes in the same column will be your pin 1. Okay. And the last 2 holes at the last column is going to be your pin 3. And all the 4 holes in the middle is going to be your pin 2. Okay. So basically, if you're looking for the resistance between your pin 1 and pin 3, as it's mentioned here in table 3, what you will do is you do the measurement between your 1 and the 2. Okay. Okay, so that's the potentiometer. Okay, since we are talking about potentiometer, we can take a look at table 3 first. Okay, so in the table 3, it's asking you what is the total resistance between terminals 1 and 3. If you can open your lab manual on page 13, okay, it says it's asking you what is the step number 4 is asking you what is the total resistance between terminals 1 and 3. So technically speaking, we're going to use the multimeter to do the measurement, okay? Because we're trying to measure the resistance. So we can put this thing into the this range. So you can see this is 20 M or 20 mega, 200K, 20K, 2K, and the smallest range that we can have is 200, okay? So because we're trying to work with the this 10K ohm resistor, so definitely we want to use the 20K. Okay, when you try to select the range, you have to make sure that this range will be able to cover the resistor that you're trying to measure. For example, if you're trying to measure a resistor of, let's see, 19K ohm, you definitely need to choose the 20K. You cannot use the 2K because it's going to be out of range, okay? The number here means that the maximum resistance it will be able to measure. So if you're using this range, it means that the maximum resistance you will be able to measure is 20K. If you're trying to measure a 1 mega ohm, for example, then you definitely need to switch to the 20 mega ohm. Okay. Let's see, if you're trying to measure 1K, for example, 1K ohm resistor, definitely you can say, definitely I can use a bigger range, but that will be less precise. So that's why we always want to use 2K to measure a 1K resistor. Okay, you can, we can take a look at that later on. Okay. Okay, so if we're so if the step number 4 is asking you what is the resistance between terminal 1 and terminal 3, so what I can do is, you can see it has 2 leads. One is the black lead and the other one is the red lead. Usually we will just put the red lead. Usually we'll put the red lead here, okay, and your black lead here. Okay. Well, actually, it says the resistance between terminal 1 and 3. So usually the red one goes first and then the black one. So it's 1 and the 3. Okay. Because, you know, it doesn't matter because the resistor does not have any polarity. But in the future, if you're trying to measure, for example, the voltage, if you measure from across, you know, between 1 and 2, terminals 1 and 2, is actually different between the voltage across 2 and 1. Okay, the polarity is going to be an issue, but for the resistor, we don't have that issue. Okay, so technically speaking, we should to do the measurements like this, but you can tell when you give it a try, you will be able to tell the probe here is actually quite big, and the hole here is very small. So it's kind of hard for us to stick the probe all the way in. So that's why when you're trying to measure the resistance across the potentiometer, you can use this way. I usually put the wires in so that we can actually kind of like extend the metal part inside of the potentiometer to somewhere that we'll be able to measure with our multimeter. Okay, so I just stick this wire in like this. So this is going to be your pin 1. And put another wire here. And this wire is going to be your pin 3. And like I said, all the 4 holes in the middle is going to be your pin 2, right? So I'll just put another wire here. You can use any of the 4 holes in here, okay? Now, if you're trying to measure the resistance between terminals 1 and 2, we just need to make sure that the 2 leads are touching the metal part of the wire, because the wire goes all the way in and make a good contact with the potentiometer. Okay, so I'll put the resistor. I'll put this thing here. Is it better like this, or okay? I'll put it like this way. Can you see it? Okay. Yeah, it's a little bit difficult to make a video. You see, everything to me is upside down, so just bear with me. Okay, so when you're trying to measure the resistance between 1 and 3, so resistance 1 and 3, okay, so you can see the numbers on the screen is 8.70. So you just put that number into the table 3. Like I said, always make sure that you have put a unit in there. Don't just put 8.7. It's in K ohm because you're using the 20 K ohm range, right? So the answer for that is 8.7 K ohm. Okay, don't forget about the K ohm. Okay, so that's how you actually measure the resistance between 1 and 3. And for step number 5 all the way to 7, it's like for different kinds of so you're basically gonna turn this knob and make sure that the shaft is at different positions, and then you do the measurements between terminals 1 and 2, as well as terminals between 2 and 3, okay? For example, step number 5, CCW here means counterclockwise. So you're gonna turn the knob all the way to, all the way down counterclockwise. So counterclockwise is this way. So turn it all the way down, and then you do the measurements, okay? Resistance between terminal 1 and 2. So this is your terminal 1, this is terminal 2. So you do terminal 1 and terminal 2. And you can see at this moment, the resistance is 0. Okay, you put that number in the table. And the resistance between 2 and 3, so resistance between 2 and 3, it gives you 8.7. Okay, 8.7. And in the last column, you just add up those two numbers together to get the sum of the resistance readings. Okay, it's going to be 8.7 ohm, right? 8.7 k ohm. Okay, and for step number 6, CW is clockwise. So you turn it all the way down to here, clockwise, and you basically repeat the measurement again. 1 and 2, 8.7, 2 and 3, 0, okay? And half counterclockwise, step number 7, is like you put the thing in the middle, like halfway, okay? And then you do the measurement 1 and 2, 4.08, 2.3, 4.73, okay? And put those two numbers in, and then do the sum, okay? Do the sum, and then and that's basically the table 3, okay, table 3. Let's come back to the table 2. So now you should be able to know how to do the measurements by using the potential, by using the multimeter, right? So, so here we have the resistors here. Actually, you're gonna have 10 of them. So you need to do the measurements like one by one, okay? So when you're trying to measure the resistance of a resistor, so you can put your red lead here, making sure the contact is good, okay? And put the black lead here, and you will see it's actually 1.46, okay? Well, you can see it's 1.46. At this moment, I'm using the 20 k ohm range, right? Remember when I talk about the 4, if your resistor is 1.5 k, is estimated to be 1.5 k, you should choose 2 k ohm, right? You should choose the range of 2 k ohm instead of 20 k. So let's take a look at the difference. When I use the 20 k ohm range, the readings is 1.46. And when I switch to 2 k ohm, and you can see the readings is 1.473. So this has more significant digits, right? So this will have more significant digits. So that's why it's going to be more precise than the larger range. Okay. So when you're trying to measure, so first thing is like you just read the color code and try to get an idea on what is the estimated value of this resistor. Okay, and then you choose the correct range, and then you do the measurements. Take down the numbers, 1.471, okay? And you basically repeat the entire process for 10 times, and then you should be able to fill out the entire table. When you're done with the measurement, the last step will be to calculate the difference in percentage, and put your result in the very last row, actually very last column in here. Okay, in here, we have the equation for the difference in percentage. It's on page 10, step number 2. Okay, so you can take a look at the equations and do the calculation. Okay, so that's basically lab number 1. If you take a look at the page 14, you will see evaluation and review questions. So those are for you to work at home. It's kind of like the homework for the lab. So make sure that you finish the questions here and include that in your lab report, okay? So basically you can see so that in your lab report, you will have the introduction of the lab. You need to put all those steps in here and make sure that you attach your tables with all the measurements that you have done in the lab, and then at the last put the review questions and the answers over there. Okay, make sure that you compile all the pages in one single PDF file and upload that file to the Blackboard. Okay, don't just put like a bunch of pictures in there. If you want to do pictures, make sure that you compile all the pictures in the correct order in one single PDF. Okay, so that is lab number one. Okay, thank you.